So, we will start today. So, we have again already discussed about different types of work done, PV work done, both isothermal and adiabatic work, and also we have looked into Joule-Thomson and Joule's expansion, and we have worked out certain problems. So, today we are going to do some more simple problems, and then if there is time we will go to the next topic. Okay. So, the first problem is for this particular cyclic diagram where A goes to B, B goes to C and C goes to A, we need to calculate the work done in the whole process. Okay. So, how you are going to approach this particular problem? So, if given that, what you are going to do? For example, if we want to do work done for A to B system, it should be pretty simple, because it is a constant pressure work. See, the pressure is not changing, it is remaining fixed at P1 value. So, it should be minus P1 and change in the volume, which is 3 V1 is the final volume, minus initial volume is V1. So, that gives us minus P1 into 2 V1 or minus 2 P1 V1, correct. So, you can see that the work is negative, which means that work is done by the system. Okay. Now, let us do the other simple one, which is C to A. What will be the work done in this particular case? The work done should be 0 in this particular case. Now comes to, so we are going in a cyclic process, A to B, B to C and C to A. So, we have to do B to C. Now, can you tell me what will be the work done in case of B to C? How you are going to do that? So, notice one thing, that B to C is a linear change, right, and there is some information in the graph to find out the relation between pressure and volume. So, we need to find out that relation. Okay. So, as you can see, it is a linear graph, right. So, change in pressure versus change in volume, which is dP by dV, we can, that is the slope of the curve, right. And what is the change in pressure? So, let us say I am going from B to C. So, I am going from B to C. So, I will get 6 P1 change, and going from B to C I will get a change of minus 2 V1, right. So, the slope is minus 3 P1 by V1, right. It is a negative slope, it should be negative, because when pressure increases volume decreases. So, that means dP equal to minus 3 P1 by V1 dV. When you integrate it, it will get P equal to minus 3 P1 by V1 into V plus C. So, we need to find out the value of C, right. So, in order to find out the value of C, we need to put some points. Let us say, let us take the point B. So, at B the pressure is P1. So, I write P1 equal to minus 3 P1 by V1, and volume is, at B volume is 3 V1, right. So, 3 V1 plus C. So, what happens is then V1 V1 cancels, it gives us P1 equal to minus 9 P1 plus C, which gives us C equal to 10 P1. Now, we get that equation P equal to, now let us see the equation number 1. So, from 1 we get P equal to minus 3 P1 by V1 into V plus 10 P1. So, P1 V1 they are all fixed values, whereas P and V's are variables. Okay. P is a function of V or V is a function of P. So, now that we get our P, the work done from B to C can be written as minus P dV integration going from 3 V1 to V1, because we are going from B to C, right. So, I will just, I am going to erase this particular part, right hand side space. So, which means now I am going to substitute P from equation number 2, which is integration 3 V1 to V1, and I will substitute P as minus 3 P1 by V1 into V plus 10 P1, this one total dV, which gives us minus, I will just now I will just straight away put the bracket, minus 3 P1 by V1 into V square by 2, I just integration of V gives us V square by 2 plus 10 P1 into V, that is going from 3 V1 to V1. Okay. Now, we are going to do again. So, minus minus becomes plus. So, 3 P1 by V1 and V square by 2 or 2 I will just put it here. So, now I get V square. V square means V1 square minus 9 V1 square, right, which gives us minus 8 V1 square. First step is done. Second step, minus 10 P1, this minus has come here, minus 10 P1. Now, V1 minus 3 V1 gives us minus 2 V1. Now, this is the last step. Now, I have 2 V1 and 8 V1 squared. So, 2, 8, 4 V1, V1 squared is V1. So, I am getting minus 12 P1 V1 plus 20 P1 V1. So, 8 P1 V1, is it correct? Okay. So, now that means now I can write here as 8 P1 V1. Now, what will be the total work done for the cyclic process, which means I can say that I can write as integration of dW over the cycle, or I can write total work in the cyclic process, whichever way I want to write. So, I have to add all that together, which gives us minus 2 P1 V1 plus 8 P1 V1 is 6 P1 V1. So, I am just going to erase it. So, if that is the case, you see I am you know what is the total in the internal energy change in the cyclic process. So, if I go from A to B, B to C and C to A, what will be the change in the internal energy? 0, because it is a state function. So, therefore, what is the total heat change in the whole process? It will be minus 6 P1 V1. So, we do not have to calculate the heat. It is not always easy to calculate the heat change, okay, because heat change formula we know, either Cv dt or Cp dt. So, constant pressure process we have only one here, which is going from A to B, okay, and there is a constant volume process is also there, Ca, that is also fine, but we do not have anything between Ac, that we will not be able to calculate, because it is neither constant pressure process nor constant volume process, nor adiabatic process nor isothermal process. So, in that case it will not be possible to calculate the heat change. So, but here total heat change you can calculate by using the first law of thermodynamics formula. Okay. So, now let us study one more problems of calculating the work done. So, here you will learn later that it is called a Carnot cycle, where A to B is an isothermal process, A to B, then B to C is an adiabatic process. So, first there is an isothermal expansion, and in isothermal expansion heat goes inside, because otherwise temperature will not remain constant. I told you that for an expansion process temperature will cool down if you do not put heat. So, in order to maintain the temperature you have to put in heat. So, this is the step where the heat goes in. Now, next is adiabatic step, where there is no heat going in or coming out, because that is why it is adiabatic, and since it is an expansion process the temperature will cool down. And then C to D is a compression, isothermal compression process, just the opposite of A to B, in which case the heat will go out, just like it is going in between A B, in C D it will go out, and D to A there is no exchange of heat, it is just the opposite of B to C, it is a compression process. So, temperature will increase. Okay. So, A, B and C, D are complementary to each other or just the opposite process of each other, where B, C and D, A are opposite processes of each other. And interestingly, the temperature of A, B is same, temperature of C, D are same, but the temperature between B and C and A and B are different. Okay. These are different facets of this particular Carnot cycle that was designed, and you will learn later that is kind of an engine that works. So, engine means any engine means you give in heat and you get some work. Our main task of working with engine is that we will get the work done, whether it is a train in which we will ride, or whether it is a pump with which we will take out water, or whatever you can think of, an engine or a car. Engine is made to do some work, the substitute manual labor by using the available energy. So, this is a heat engine where heat will be used to do the work. So, let us see how much work this engine can get us. Now, you see, in order to calculate the total work, we have to do it again stepwise. What is the work done in W A to B? If you remember the formula, it is minus, it is an expansion process, remember. So, work done will be on the system will be negative. We always calculate work done on the system, right, and since it is an expansion process, work done on the system is a negative work done, that means system is doing the work. So, it is minus nRT A or B basically the same, because it is a constant temperature process. So, I am just writing as T A. I will just note it down here that T A equal to T B and T C equal to T D, ln V B by V A. Okay. That is a formula I am using, that which we have already derived for isothermal work. We have already derived that, so that is why I am not doing it. Now, for B to C, we have also derived this. What was that? C V T C minus T B. Let us call it T A, because T B and T A are same, na. In fact, since T A and T B are same, we can call that as T H, high temperature, and T C and T D are same, let us call it C, cold. Here the C is cold, high temperature and hot reservoir and cold reservoir basically. Okay. So, we are just going to replace A by H and C by cold. Okay. And I will also explain what is hot reservoir and cold reservoir. Hot reservoir is something in which, like, where the reservoir is supplying you energy, it is kept at high temperature. A cold reservoir is where a reservoir is colder than the system, which will take out the heat from that. That is the definition. And reservoir is, as I told you, that is a very big system, therefore, its temperature is not going to change if you give in little bit heat or take out a little bit of heat. Okay. So, now what is the work done from C to D? No, we have gone to B to C, right. So, C to D, it will be exactly opposite of A to B. So, it will be plus nRT, or rather you use the same formula. So, minus nRT C ln V D by V C. You see, V D, volume of D is smaller than volume of C. So, this particular term is already negative, and negative will make it positive. So, it is actually a positive work done on the system. Okay. But we do not have to worry about which is positive and which is negative. We can use the same formula, and the formula is minus nRT ln V final by V initial. Now, the last step, D to A, again C V T H minus T C. Okay. Is it correct? Now, what is the total work done then? Minus nR T H ln V B by V A minus NR TC ln V d by Vc plus Cv Tc minus Th plus Th minus Tc. So, you can see that this gets cancelled out and only this is remaining, and we can take minus NR common and it will be Th ln Vb by Va plus Tc ln Vd by Vc. So, we can simplify it even further and we can write W, writing it again, we can say that W equal to minus NR Th ln Vb by Va plus Tc ln Vd by Vc. Now, just to remind us, the Carnot cycle in PV diagram is A to B is an isothermal process, B to C is an adiabatic process, C to D is an isothermal process, and D to A is an adiabatic process. I will denote by I as an isothermal and A as an adiabatic. Now, I can use the relation between B and C, which are 2 points connected by an adiabatic reversible path. So, the connections that you know between them, the relation is that the temperature at point B and then volume to the power gamma minus 1 at point B is temperature at point C and volume at point C to the power gamma minus 1. And we know that Tb is nothing but Th. Both A and B have same temperature Th, which is the high temperature, and Vb to the power gamma minus 1 is Tc. C is now cold, C means cold now. So, this is Th and this is Tc, Vc to the power gamma minus 1. So, that is equation 1. Similar relation you can have between D and A, and we can write Ta Va to the power gamma minus 1 is Td Vd to the power gamma minus 1. Ta is nothing but Th Va to the power gamma minus 1, and Td is Tc Vd to the power gamma minus 1. So, let us call it 2, and then dividing 1 by 2 we get Vb by Va to the power gamma minus 1 is Vc by Vd to the power gamma minus 1, or Vb by Va is Vc by Vd. Let us call that 3. Now, use this equation relation in 3. In this equation we can get minus NR Th ln Vb by Va plus Tc ln it is Vd by Vc will be Va by Vb, and then we can write it again using the formula as minus Tc ln Vb by Va, and then we can take ln Vb by Va as common and write Th minus Tc. So, this is the work done for the cyclic process in the Carnot cycle going from A to B to C to D, and this is the simplest possible relation that we can write down. And now, we can also calculate the efficiency from this. So, efficiency of that particular engine is work done by heat input. Now, heat input has happened, as you know, between the first isothermal process going from A to B. Now, we have done already the work done from A to B. So, work done from A to B, as we have seen, is minus PdV, and then we have written that as NR Th ln Vb by Va. And we know that UAB is 0 because there is no temperature change. So, therefore, work done, therefore, heat input Q in equal to QAB, that is negative of WAB, which is plus NRTH ln Vb by Va.
let's call this one as equation 4 and this as equation 5. So therefore this one we get as minus nr as w ln Vb by Va Th minus Tc divided by Q in we got from 5 as plus nr ln Vb by Va. Now nr ln Vb by Va cancels. Oh, and Th is also there, cancels each other, so we get minus Th minus Tc by Th, or we get this as minus 1 minus Tc by Th. So there is, you have to see, there is a minus should not be there. So if I say that this is this W is work done on the system, so therefore work done by the system will be minus W. So minus W is the work that system is doing. There will be plus, there will be plus, and there will be plus. So the efficiency of the engine, now if I use a different color, is eta equal to 1 minus Tc by Th. So this is the efficiency of the engine, Carnot engine.